So let me share with you the importance of physical, or rather the importance of chem bonding. Right? Most of the question will be along this line. Okay, so I'm going to share screen with you. We're going to use the whiteboard, and that's all. All right, discussion from the start to the end. So again, the session will be recorded. All right, and then you can review over and over again. So here we go. Okay. All in all, why do we study this? Okay, be very honest with you. All right, is all the way right at the bottom. We want to predict something called the physical properties of a compound. All right, physical properties of a substance, not just a compound. Any substance. That's the end or stage. All right, you study bonding for this purpose. Chemists study chem bonding is because of this purpose, to predict the physical properties of substance. Can someone give me some examples of physical properties? Type or might up, either way is good for me. All right, what is some example of physical property? Let's do it. Go. Since Sec 3 until now, it's always that few. Can I have some example of physical properties?
Boiling point.
Boiling point, very good. Boiling point.
Electricity conductivity.
Electrical conductivity, all right? Electrical conductivity, all right? Anything else?
Solubility.
Solubility, all right? Solubility, solubility, all right? Let me write properly for you. Okay, my pen is a bit blunt already. Been writing a lot. Need to get a new one. All right, a couple of you guys typing out. Very good. Solubility, all right? So you must start with the end in mind. Okay, oops. All right, else you're just blindly reading your notes without understanding what you're doing. Solubility itself, and solubility, there are two types. All right, solubility in water as well as solubility in organic solvent. All right, so this is what you want. So let me take a look at the chat. Viscosity, malleability, ductility. I'll take all this: melting point, boiling point. All right, very good. All right, viscosity, density. All these are very common physical properties. So that's the aim. Now, we know there are three types of bonding, and thus the structures. There are four types. You have your ionic, so ionic compound, ionic structure, giant ionic structure. Metals, you have your metallic bonding, then giant metallic lattice structure. Then you have your covalent bonding. There are two types of structure, the small one and the big one. Small one is your simple molecular structure, and the big one, giant molecular structure, right? So giant is just like similar to what we did in Sec 3. We still want you to know that three of them, the diamond, the graphite, and the sand, right? Silicon dioxide. It's still that three. Anything else they give you in terms of giant molecular structure, it will be based on that three, right? It must be something similar to them. Then they give you clues and you apply. So I always told you the bulk of it. 95% of question have to do with your simple molecular structure. So basically, we are predicting the physical properties of what? The key things that I want to discuss today is your SMS, simple molecular structure, the small molecules. Okay. So to do that, right, your small molecules, all right, what are we looking at? So all in all, what are we looking at? So let's see whether I have enough space here or not. Now, so they will always give you, all right, you'll be given the name, if not the chemical formula, right? The chemical formula of all the questions like this, all right? I'll say 99.9999%, all right? Chemical formula of your SMS, simple molecular structure, all right? You'll be given it, okay? They'll give you this, and then they start to ask you things along the way, all right? The best one is whereby they link to the aim, which is the physical properties of the substance, all right? Else, it will be from the start, then they give you a formula, then they ask you, what do you think is about physical properties, all right, of this compound? So what we're doing in, what we did in part 2 notes was talk about the, it all starts here, right? We talked about the dot and cross diagram. I showed you before, you must be able to draw your dot and cross diagram. Okay, dot and cross diagram. You cannot draw this, then skip the whole question. Don't waste your time. You just guess and check, and most of the time is wrong. All right, it's a fact. So after dot and cross diagram, can someone mind up what do we need to do? In order, we talk about polarity of molecules. Remember, somewhere along here, I just anyhow scribble here. All right, polarity of molecules. I'm going to erase this one because I got more things inside here. So how do we get to the polarity of molecule? Remember the steps or not? Anyone? So you get your dot and cross diagram. Oh, happy. Go through all the rules.
Is
Yeah,
it
happy.
Is it bond pair, lone pair?
Bond pair, lone pair. So what you want to find? You're finding the
shape.
shape. All right. Thank you very much. What you want to do is to find the shape. All right. So don't copy in first. Later, then take a snapshot. All right. So listen up first. Let's discuss. I want you to recap what's important. All right. So all in all is after you got a dot and cross diagram, you want to find what we call the molecular shape. Or you want to find the shape of the molecule. Why? Okay. Because, all right, probably even before there, all right, how can we get the shape of the molecule from dot and cross diagram? So over here, what do we need to do? So you got dot and cross diagram. Is it Simajot? She was telling us need to find the what? Need to count the bond pair, lone pair, right? But before bond pair, lone pair, remember what is it not? We need to count the what? The number of electron pair. Because with the electron pair, what we have first? Someone. We have the electron pair, start with G. Hello, electron pair what?
Geometry.
Thank you very much, right? So in your syllabus, how many geometry do you need to know? Anyone? By fingertips.
6.
6. All right. I think it starts with electron pair 2, 3, 4, 5, 6. So total there's 1, 2, 3, 4, 5. There are only 5. Okay. Times 5 of them. Okay. So there are 5 electron pair geometry. Then after that, we do what? All right. Like what Simajit told us, we then count the number of bond pair and lone pair. All right. And that's where we'll get the molecular shape. But with the bond pair, electron pair, let me write properly. All right. The bond pair and the electron pair. Oh, my pen is not very sharp anymore. All right. So bond pair and the lone pair. All right. We say we cannot see what? So that you will get your molecular shape. These are actionable steps. Follow through. Anyone? Cannot see what? Singlish, I told you. All right, lone pair. Thank you very much, Bunket. You cannot see the lone pair. So just the bond pair itself without a lone pair, all right, it'll give you a what? All right, it'll give you your molecular shape. All right, you get you your molecular shape. Okay, this was the tip I told you. All right, cannot see lone pair, you get a molecular shape. Now, with the molecular shape, so what? How do you get to the physical property of the substance? All right, so the molecular shape. All right, then with the shape, you then decide what? You're going to look into the, this should be number 3, the polarity of the molecule. Not nice, let me do it properly. All right, we look into the polarity of the molecule. Is the molecule polar or not? All right. So we did until here. So for molecular shape to here, what do you need to do? So that every time you look at the question, right, they'll test you either along the line one. Sometimes from the start, then you have to go all the way, or sometimes middle of it, you work backwards. Can you see that it's a line? You can work backwards on. So you must have the ability to know what you're doing. How you go from your house to your school, you must know what to do. And from your school back to your house, you must know what to do. Very important. What are the steps? What is the route? So molecular shape, you have the shape already, so what? Then you talk about the polarity of the bonds, right? You talk about the polarity of the bonds, right? Polarity of the bond or bonds. Because as we mentioned, all right, let me give a bit of space. You need to find out what? You need to find out whether there's any polar bonds there. We just did this, right? If none of the bonds are polar directly, I know the molecule is non-polar. However, if the molecule has at least one bond that is polar, the molecule may still be polar or non-polar. All right, it can be polar or non-polar. It all depends whether what? Whether the dipoles cancel out or not. All right, the individual, whether they cancel out or not, whether they cancel out. So ask yourself this question. So all in all, you have to tell people keywords, right? Is there a available dipole moment, which is what I call the sum vector, like physics and math. Remember that? So every time there's a dipole moment, then I know, yay, there is it's a polar molecule. There's no dipole moment, it's a non-polar molecule. All right, we discussed about that. So polarity of molecule is here. Then what else? We will then talk about what? We will then go into talk about physical properties. So what we did in part 2 notes is until here. All right, point number 3. All right. So this week, some of you will be meeting me as early as tomorrow, right? The Tuesday class. Else, the Thursday, if not the, I think, Saturday class. All right. We'll be looking at point number 4. All right. Whereby we then talk about what? We then talk about your intermolecular forces of attraction. Right? And they are what? They are between the molecules, your small molecules, simple molecular structure. Right? So it's from here, you come here. So this week we're going to talk about this. So I'm expecting everyone to be good with the first 3 points. All right? So you cannot say, oh, Mr. Chua, how you know it's polar? I will say, I covered a long time ago. Okay? Don't know. Revise your notes. Okay? So you'll get your intermolecular forces. And intermolecular forces, what are the 3 that you have? All right. Again, from the weakest is ID. You have the middle one called PD. And again, we have a lot of things to discuss there. But I need to make sure that you know how we ever reach here. It has to do with the polarity of the molecule. Because once the molecule is non-polar, all right, so it has only ID. However, if it's polar, it can have this. Let me write it down, right? If the molecule is polar, then it could be either PD or H bonding. All right, so that's where we have our 3 types of intermolecular force of attraction. And we all know PD and H bonding are stronger than ID. And that's where we can then come down and say, oh, I finally can predict whether the melting point, boiling point is high or not, whether it dissolves in water or not, things like that. All right. So if I know a compound is having hydrogen bonding between its own molecules, I'm very sure that the melting point, boiling point are usually higher than the other molecules. So yeah, that's a physical property of substance. So again, we move it down this way. All right, we move it down this way. And this is the only way. But don't forget, all right, in the question, I could give you question like the physical property of the substance. Correct? So I give you usually in the form of what? Since Sec 3 until now is like this. Correct? With the compound, say X, compound called Y. Then I give you the what? I give you the melting point. I give you the electrical conductivity, EC, example, electrical conductivity. Right? Then high or low, whatever. So from the values here, all right, from the values here, you will also be able to do what? You'll be able to know X and Y, all right, what kind of intermolecular forces they have. All right, it's vice versa. What? It's either go down or come up. So basically this, you can go back. So I need you to be very good in moving along the line to be able to solve all kinds of questions regards to simple molecular structure. I need you to be able to move. By right, it all starts here, but as we move down, we can also come back. Okay. And normally we start around polarity or molecular shape. We go back, we don't go back to dot and cross diagram lah. All right, that's why I put another arrow all the way up. All right, something like that. Again, look at questions, you know what I'm talking about. All right, so if you want, you can take a snapshot of this. You can take a snapshot of this. The video, oops, give me a moment. I click delete all. All right, the video should be up on the website either tomorrow, if not the day after. Okay.